I'm Anil Kumar, and in this video I've taken a few examples based on difference of squares, and we'll see how to factor such binomials. So you'll see whenever we have examples for difference of squares, we are dealing with binomials, not trinomials, right? The formula which you can always use is a square minus b square is equals to a plus b times a minus b, right? So that is the formula. When you expand a plus b times a minus b, you get a square minus b square. Now the first one here is x square minus 1. So a is kind x, b is 1, and you could straight away write this in factored form as x plus 1 times x minus 1. Now let's look into the second example here, which is 16x squared minus 9. Now think about it like this. 16 is 4 square. So it could be written as 4x whole square minus 9. 9 is 3 square. 3 square. Now you can compare a square minus b square. A is 4x and b is 3. So I could factor this as 4x plus 3 times 4x minus 3. You got it, right? So that is how it should be done. So these examples they look similar, but they're kind of different. So there is a variation which should help you to solve most of the examples of this kind. Now next one here is 50 minus 8x squared. 50 is not a perfect score, nor is 8, right? But if I take 2 common, then what it becomes? So if I take 2 common, then I get 50 divided by 2 is 25, and 8 divided by 2 is 4. So we get 4x squared. Do you see perfect squares now? Yes, we do. 5 squared and 2x squared, correct? So we could write this as 2 times, let me rewrite this first, as 5 squared minus 2x whole square, right? That helps you to identify difference of squares. And then we'll write down the solution. 2 times 5 minus 2x times 5 plus 2x. You get it? So that is how it can be factored. So in this example, we first found a common factor and then we applied difference of squares. Perfect? Okay, so let me just mark this as like this. Let's continue. 3x squared minus 12, what can you do now? Take 3 common, right? So take 3 common, you're left with x squared minus 4. 4 is 2 squared, so you could write this as 3 times x plus 2 times x minus 2. Perfect. I'm not writing 2 squared, it's kind of obvious by now, right? So these are 4 examples which are kind of with slight variation, but I hope you get the concept here. So we have a list of videos which can help you practice more. You can check that list. I'll provide a link here. Okay, the next one is kind of difficult. I mean, it's new level, right? Now here what we have is not just a one term. This is a binomial terms, right? But you see squares over there. So it's kind of a squared minus b squared. A is 1 plus x now. And b is 2x minus 1. So I could write this in factored form. What I'm trying to say here is treat this as a and treat this as b, right? So I'll write this as a plus b. So let me use this bracket. A plus b means 1 plus x, right? Plus 2x minus 1. This is my first factor, a plus b. And the second one will be a minus b. That is to say 1 plus x minus 2x minus 1. Do you see that? Square brackets help us to, see easily what we are trying to do. Now we can combine the terms. 1 minus 1 is 0, x plus 2x is 3x. So we get 3x from the first term, right? So let me write these brackets. Here, x minus 2x, right? If you combine these two, then you get minus x, correct? correct? And if you combine these two, minus 1 is plus 1, you get 2. You get 2 plus 2. So what we get here is 2 minus x. Do you see that? So you could write this as 3x times 2 minus x, correct? So that is how you can do factoring of this example, correct? Now the next one here is to the power of 4. Now how do we treat this as difference of squares? You could write, let me write here, x square whole square, that becomes power of 4. Do you see that? Minus 16 is 4 square and 4 is 2 square, right? So we could write this as 2y square whole square. Rather, let me write 4 square is 16. So 4y square whole square. Okay, so we'll write like this. 4y square whole square. We'll make it 2 square later. Okay, so that means a is x square and b is 4y square. So I'll factor this as x square plus 4y square times x square minus 4y square. Is it okay? Now first term has a plus. It is not difference of squares, so we'll just copy it as such. However, this term can be further factored. 4 is 2 square. So we could do it as x plus 2y times x minus 2y. Do you get it? I wanted to write 2 square here just to make it obvious. But I hope now it's clear. 4 is 2 square. So x square minus 2y whole square. That could be written as x plus 2y times x minus 2y. Correct? So that is completely factored. So now you cannot further factor it. That is what we mean by saying completely factored. So I hope these 4 examples which I have taken up help you to really solve such questions which are involving difference of squares. Correct? So these 4 questions are good questions to practice. I'm Anil Kumar. You can always share and subscribe to my videos and feel free to post comments. Thank you and all the best.